Welcome to all. So in this session I am going to explain the experiment number 3, design and implementation of 4-bit binary adder, subtractor and BCD adder using IC 7483. So in this circuit we need for IC 7483. So it is a 16 pin IC used for this applications. So they perform the 4-bit binary adder and subtractor performance. So 4-bit binary adder means, so we want to add 4-bit to binary numbers. So 4 inputs, this is our input. So input set A, it has 4-bit A3, A4, A3, A2, A1 and input B, B4, B3, B2, B1. So in this case, so we want to add these two 4-bit binary numbers. So output is, so sum is S4, S3, S2, S1 is some value, 4-bit sum value is available and 1 carry is available. So this is the pin diagram for IC 7483. It is a 16 pin IC. So pin number 1 to 8 this side, pin number 9 to 16 this side. So we want to use input A and input B. So this is the logic diagram for IC 7483. So this is 4-bit binary adder logic diagram. Input 4, A4, A3, A2, A1 is the input A, B is called B4, B3, B2, B1. So we want to give input A4 for the pin number of IC 7483. A3 is given to pin number 3, A2 is given pin number 8, A1 is given pin number 10. Similarly, B4 is connected to pin number 16, B3 is connected to pin number 4, B2 is connected to pin number 7 and B1 is connected to pin number 11. So here this is the C is equal to 0, that is mode selection switch. In this we want to give 0 for the addition operation. This is given to the 13th pin. So 12th pin is ground. So 5th pin is VCC. So 14th pin is carry output. So we have only one carry. So 14th pin is carry. So some 4 binary bits. So S4 is connected to 15, S3 is connected to 2 and S2 is connected to 6 and S1 is connected to pin number 9. So this is the connection diagram and logic diagram of 4-bit binary adder. So as per the circuit diagram, logic diagram, so we have to connect the connections in the digital trainer kit. So this is the truth table for 4-bit binary adder. So here to input A and input B, it is 4-bit, it is also 4-bit. Here addition have the 4-bit sum value and 1 carry. So if you give the input 1 0 0 0, similarly 0 0 1 0 means sum will be carry, sum will be 0. So carry will be 0, S4 is equal to 1, S3 equal to 0, S2 equal to 1. So similarly we want to apply the remaining inputs. So we get the expected sum and carry. So in this as per the truth table. So now I am going to implement this and verify this truth table in digital trainer kit. So this is the input port. So we want to give input A 4 bits and input B 4 bits, totally 8 input bits and 1 selection mode. C is equal to 0 for addition operation, and so we have the 4 output, sum output S3, S2, S1, S0 and 1 carry output. Pin number 10 is output 10 is connected to carry. So in this, so I am going to use the IC 7483. It is a 16 pin IC. So already mentioned the pin diagram and connection diagrams as per the logic diagram. So we give the all the connections. VCC given to the pin number 5 and ground is given to pin number 12. So 1, 3, 8, 10 is the input A, 16, 4, 7, 11 is the input B. So VCC is 5, ground is connected to pin number 12. So carry output is pin number 14. So 15, 2, 6, 9 is the sum output. So now I am going to give the input for the first sequence. So A3 is equal to 1. So A4 is equal to 1, A3 is 0, A2 0, A1 0. So B4 is equal to 0, B3 is equal to 0, B2 is equal to 1. So and our output is as per the truth table. So carry is equal to 0. So here carry is equal to 0. So S4 is equal to 1 and S2 is equal to 1. So for input, A4 is equal to 1, A3 is equal to 0, A2 0, A1 0, B4 0, B3 0, B2 is equal to 1 and B1 is equal to 0. So in this case, so carry is equal to 0. So sum will be in S4, Y is equal to 1 and S2 is equal to 1. So next input is 1, 000, B4 is equal to 1 and B3, B2, B1 is equal to 0. So in this case, so carry is equal to 1, remaining sum value, all the sum value will be 0 as per the truth table. So third input is, input is 0, 0, 1, 0. So B4 is equal to 1. So remaining values are 0 means, so we get the carry value is equal to 0 and S4 is equal to 1, S2 is equal to 1. So next combination, so A4, A3, A2 is equal to 1, A1 is equal to 1. First three combination is 0. So A1 is equal to 1. So B4 is equal to 0. So B3, B2, B1 value is equal to 1 means, so in this case carry is equal to 0. So S4 is equal to 1. So this is the output. So next input is 1, 0, 1, 0. B value is equal to 1, 0, 1, 1 means in this case carry is equal to 1, S3 is equal to 1 and S1 is equal to 1. So next input is, so A3, A4, A2 is equal to 1, A1 is equal to 0. So input B4, B3, B2 is equal to 1 and B1 also equal to 1 in this case. So carry is equal to 1, S4, S3, S2 is equal to 1, S1 is equal to 0. So last combination, so 1, 0, 1, 0. So B4 is equal to 1, B3 is equal to 1, B2 is equal to 0, B1 is equal to 1 means, so in this case, so carry is equal to 1, S4 is equal to 0, S3 is equal to 1, S2 is equal to 1 and S1 is equal to 1. So from this digital trainer kit, so we verified the truth table for the 4-bit binary adder. So next, this is the logic diagram for 4-bit binary subtractor. This is the logic diagram of 4-bit binary subtractor. So here two input A4, A3, A2, 1 is the input A, B4, B3, B2, B1 is the another input. So in this, so we want to use a NOT gate 7404 to invert the B4 into inversion and given to the 16th pin, similarly 4th pin and 7th and 11th. So after inverting the B4, B3, B2, B1, we want to give 16, 4, 7, 11. Remaining connections are similar to the binary adder. So here two output S4, S3, S1, S2. So in here in this case, that's the carry one. Carry is one carry and this is a difference value. So this is the truth table for binary 4-bit binary subtractor. So here A4 is equal to 1, A3 0, A2 0, A1 is equal to 1. Similarly B4 0, B3 0, B2 1, B1 is 0 means in this case, so borrow value is equal to 1. So difference 4 is equal to 0, difference 3 equal to 1, difference 2 equal to 1, difference 0 is equal to difference 1 is equal to 0. So next case 1 0 0 0 A. So B value is equal to 1 000. So in this case we get the borrow value equal to 1. D4 is equal to 0, D3 is equal to 0, D2 also 0, D1 also 0. So next case 0 0 1 0 means A value, B value is 1 0 0 0. So in this case we get the borrow value is equal to 0, difference 4 equal to 1, difference 3 equal to 0, difference 2 equal to 1, difference 1 is equal to 0. So last case, so similarly 1 0 1 0 means, so B value is equal to 1 1 0 1 means finally we get the borrow value is equal to 0, D4 is equal to 1, D3 is equal to 1, D2 is equal to 0, D1 is equal to 0. So in this concept, so we want to subtract the input A from input B. So difference value is mentioned here. This is the 4 difference value and 1 borrow value is available here. Going to verify the truth table of 4-bit binary subtractor using digital trainer kit. So this is the input port. So now we want to give the A4, A3, A2, A1 here. Similarly B4, B3, B2, B1 here, and one more selection switch. So connected in port number 9. So this should be always high for the subtractor. So this is the output port. So we have the 4 output, that is 4 difference D3, D4, D3, D2, D1, D0 and 1 carry, that is 1 borrow for the subtractor purpose. So here we are using the 2 ICs. So first one is IC 7483. So second one is IC 7404. So as per our circuit diagram, so we made the connections. So now I am going to verify the truth table. So first input is A4 is equal to 1 0 0 0 means B4 is equal to 0 0, B2 is 1 and B1 is equal to 0. In this case, so borrow is equal to 1, D4 is equal to 0, D3 is equal to 1, D2 is equal to 1, D1 is equal to 0. So now I am applying this input in digital trainer kit. So A4 is equal to 1, A3 0, A2 0, A1 0, B4 0, B3 0, B2 is equal to 1 and the selection mode switch is equal to 1. So in this case, so I am getting the borrow value is equal to 1 and difference D3 is equal to 1, D2 is equal to 1. So as per the truth table, so this is verified. So next input is, so 1 0 0 0 and B4 is equal to 1, B7 is equal to 0. So in this case, so borrow will be 1, so difference will be 0 for all the cases, D4, D3, D2, D1 will be 0. So next combination is, so we want to give A3 is equal to A4 equal to 0, A3 is equal to 0, A2 is equal to 1, A1 is equal to 0, B4 is equal to 1, B3 is equal to 0 and the remaining answer also input also 0. So finally we get the output borrow is equal to 0. So difference is equal to D4 is equal to 1, D2 is equal to 1. So this is our input. Only A3 is equal to 1, B4 is equal to 1 and CE, that is mode selection is also 1. So in this case borrow is 0, difference is D4 is equal to 1, D2 is equal to 1. As per the truth table, it is also verified. So next case, so input is 0 0, A1 is equal to 1, B4 is equal to 0. So remaining 3 values are 1. So in this case, so as per the truth table, so borrow is equal to 0. So difference D4 is equal to 1 and D2 is equal to 1. Remaining 2 values are 0. So next input is, so A4, A3, A2 is equal to 1. So A1 is equal to 0. So B4 is equal to 1. B3 is equal to 1. B2 is equal to 1. B1 also 1. So all the B values are equal to 1. In this case, so borrow is equal to 0. So difference will be all the values are equal to 1. So this is verified in the trainer kit. So input is 1 1 1 triple 1 and 0. B4 is equal to 1, B3 is equal to 1, B2 is equal to 1, B naught is equal to 1. So all the B value is also 1. So in this case borrow is equal to 0, difference 4 value is equal to 1. The last input is, so I am going to give input is 1 0 1 0. So B4 is equal to 1, B3 is equal to 1, B2 is equal to 0, B1 is equal to 1. So in this case, so borrow is equal to 0, difference 4 is equal to 1, difference 3 is equal to 1, difference 2 is equal to 0, difference 1 is equal to 1. So this is applied in the trainer kit. So now I am getting the output, borrow is equal to 0, in difference 4 is equal to 1, difference 3 is equal to 1, difference 2 is equal to 0, difference 1 is equal to 4. So from this implementation I verified the truth table of 4-bit subtractor using IC 7483 IC.